Hello and welcome back. In the previous section, we discussed the evolution of generative AI as well as the key differences between discriminative and generative AI. So this section will help you understand the foundation models, which are the key constructs of generative AI. So this section gives you a thorough introduction to foundation models, and then we'll take a closer look at how they are actually trained and what are the key characteristics. Then I'm going to introduce the types of foundation models, predominantly large language models and diffusion models, which are used for generating images. And then we'll take a look at the evolving landscape of foundation models. This is very interesting because this landscape is constantly evolving and there are different types of foundation models that you can tap into. Finally, I have a very interesting topic that talks about the foundation model supply chain, where it all starts, how it actually gets processed and where it ends up and how you consume. So that's the business of the foundation model supply chain. So we have very interesting topics ahead. Stay tuned and let's get started. So in today's AI landscape, foundation models have become a cornerstone, revolutionizing how developers approach machine learning. But what exactly are these models and why have they garnered such attention? Well, the journey of machine learning has been nothing short of captivating. In the early days of rule-based systems, we ventured into deep learning, where models learn from data rather than hard-coded rules. The recent evolution saw the rise of transformer architectures, which we will take a look at in the upcoming sections. With these breakthroughs, like BERT and GPT, marking pivotal moments in the development of foundation models, we have a new architecture leading us to what we call today as foundation models. Foundation models are large AI models that have been trained on massive amounts of unlabeled data, typically through a technique called as self-supervised learning. This process produces generalized models capable of performing a wide range of tasks with remarkable accuracy. Now, these tasks typically include image classification, natural language processing, and question answering. At its core, a foundation model is a neural network pre-trained on large corpora, absorbing vast amounts of information. Unlike traditional models that are trained from the scratch for specific tasks, foundation models follow a layered approach. So at the bottom of this stack, at the very first step, there is generic pre-training over extensive data where the model learns from diverse content ranging from text to images. Then we have domain-specific refinement that further narrows the model's focus. For example, in a typical case of LLM, we might initially train the base model with a lot of data available in the public domain and then refine it to make that more instruction-driven, where we can interact with it like a chatbot. So that defines the second step, which is the model's domain-specific refinement. And finally, precision fine-tuning is meant to achieve a specific task, like text generation, image recognition, or any other AI task. This goes through another process or another cycle of fine-tuning where we actually deliver a foundation model that is capable of doing a specific task. For example, the GPT-4 is a model that is designed not just for word completion, but to behave like a chatbot through conversational interface or through a conversational interaction. So that is what is precision fine-tuning all about. So before these large foundation models enter the scene, the norm was to build models for specific tasks, often from scratch. This approach was resource-intensive, time-consuming, and heavily reliant on large labeled dataset. For example, in the domain of natural language processing, we had to train models to perform, for example, sentiment analysis, classification, and word completion, and word prediction, and so on. So each of these tasks were purpose-built models trained to do a specific task. Whereas when it comes to foundation models, we use general purpose semi-supervised learning where the model is capable of adopting a variety of tasks and delivering variety of outcomes based on the use case and scenario. So with foundation models, there are three major advantages. The first one is a reduced cost. The reduced need for training leads to significant cost saving, and it makes the deployment very swift and rapid. So we have large providers, model providers, and platform providers, for example, like Meta, Google, OpenAI, Cohere, training these foundational models and delivering the capability for fine-tuning these models for variety of use cases. So the cost of fine-tuning a model is far lesser than pre-training it or training the foundation model from the scratch. So fine-tuning saves a significant cost by eliminating the need to pre-train the model. So the second advantage is that they are flexible and adaptable. They understand the context, decipher nuances, and adapt to different scenarios more fluidly than their narrowly trained, purpose-built counterparts. And finally, it's all about accessibility. Foundation models led to the democratization of AI, allowing even those without deep AI expertise to harness the power of deep learning and neural networks. So in the next lesson, we'll take a look at the key characteristics of foundation models. Foundation models have emerged as transformative entities in the history of AI, redefining the landscape of machine learning development and deployment. They have been called everything from game changers to trendsetters. But what are these models, and why are they held in such high regard? Let's delve into the intricacies of foundation models. So foundation models are large-scale machine learning models that are trained on a broad data set, a variety of data from text, images, and other types of corpora. The first step in developing a foundation model is to collect a large data set of training data. This data is very diverse to ensure that the model can learn to perform a variety of tasks. Once the data is collected, it is pre-processed to clean up and remove any errors. The next step is to train the foundation model. This is a computationally expensive process that can take several weeks or even months, depending on the data set, for the completion. Once the model is trained, it can be adapted to perform a specific task by fine-tuning it on a smaller data set of a labeled data set. Foundation models can be adopted to perform a wide variety of tasks such as text generation, translation, image classification, and question answering. At the heart of a foundation model is the idea of extensive pre-training on large-scale datasets, followed by task-specific fine-tuning. Unlike the models of the past, which were often trained from the ground up for a specific task, foundation models provide a broad base upon which specific applications can be built. So there are three key characteristics when it comes to foundation models. Number one, foundation models are designed to consume vast amount of information in the form of large data sets. Second, they are designed to understand the context, decipher the nuances, and adapt to different scenarios more fluidly than their narrowly trained counterparts. And third thing is the ability for adaptation and fine-tuning. Foundation models can be fine-tuned to excel in specific domains or tasks. For example, a large language model can be fine-tuned to understand the nomenclature and the terminology related to, for example, the medical domain or the finance domain or any other line of business or industry vertical that has a specific terminology or a specific taxonomy. That is essentially the fine-tuning process where a general purpose foundation model is adopted for a specific domain or an industry vertical or a specific use case. So let's take a closer look at the types of foundation models. So the most popular ones are the LLMs. The LLMs are large language models, are machine learning models that process and generate natural language using deep learning techniques. We will in fact take a closer look at LLMs and how they function in the upcoming videos of this series. But coming back, LLMs are trained on massive data, massive amounts of predominantly textual data, and they are capable of performing a variety of language-related tasks, including language translation, text summarization, and question answering. Because of their outstanding performance on various natural language processing tasks or techniques, transformer-based LLMs have gotten a lot of attention. Today, a lot of AI chatbots are powered by LLMs. Now, some of the examples of foundation models that deliver the LLM capability are GPT-4 from OpenAI, BERT and Roberta from Google are some of the examples. Now, apart from the large language models, we have another type of models called the diffusion models. Now, these are generative models that generate new data that is similar to the original data on which they are trained on. And these models work by introducing what is called as the Gaussian noise into the training data and then learning the reverse to process the noise that was injected and recovering the original data from it. So these type of models can take a new data, for example, a new image, and depending on how they are trained, they can regenerate the original image or the data in a completely new format. So obviously, these diffusion models are used with image generation foundation models. For example, DALL-E from OpenAI, Imagine from Google, and another foundation model called Glide. So if you have heard of a tool called Midjourney, that uses one of the diffusion models to generate photorealistic and hyper-realistic images, which are generated by one of the foundation models. And even some of the audio models leverage the technique used by the diffusion models. So in the upcoming sections of this series, we will take a closer look at both LLMs and diffusion models and learn how to integrate them into our applications. So let's go ahead with the next section. So the foundation models powering generative AI can be classified into three broad categories depending on their licensing model. So let's take a closer look at them. The first one is the commercially available models. So the source code for the training, the source code used for training the models, the weights, the artifacts needed to host the models are undisclosed by the provider. So these foundation models are typically exposed through an API that developers can invoke. So think of this more like a platform as a service, but foundation model as a service. So in this scenario, you don't have access to the actual model, but it is obscured and concealed through an API that you can invoke. So you typically sign up with the provider, grab the API key, and then start consuming the LLM capabilities. So some of the examples of commercial models include GPT-4 from OpenAI, Command from Cohere, Claude 2 from Anthropic, Palm 2, Imagine, and Chirp from Google. So all these are foundation models, but they are available only through an API, and you cannot host them within your data center or in your own cloud environment. They are available within the context of the model provider. So that's about the commercial models. Now let's take a look at the open source model ecosystem. So open source foundation models are generally available under the Apache 2 license or the MIT license. Now, both are quite permissive and allow for commercial usage, distribution, modification, and private use. So models based on these licenses come with the source code that is included for training, inference, and even fine-tuning. They are also coming along with the weights that are published in the public repositories such as GitHub or Hugging Face. And by the way, we are going to take a closer look at what Hugging Face is and how we can leverage that to consume open source models in the upcoming videos. Now, coming back to the open source models, these models also disclose the data sets that are used for pre-training the models. Now, that's quite useful to understand what is the original knowledge base for these LLMs or the foundation models and what you can expect from them. So they are pretty transparent in the approach that they have taken to pre-train these models, including the original data sets on which these models are trained. Some of the examples of open source foundation models are Falcon from the Technology Innovation Institute from Saudi Arabia, T5 from Google, Dolly from Databricks, and Bard from Suno. Now, all these models are quite permissive and they allow for both commercial and research usage. So let's take a closer look at the custom licensed models, which come somewhere in between commercial and open source. So foundation models with custom licenses come with specific instructions on the usage and distribution of the model. The provider may or may not publish the source code used for training or disclose the data that is used for pre-training. These models may even have restrictions on usage based on the number of active users or number of invocations. For example, the Llama 2 foundation model from Meta has a custom license that requires additional permissions and approvals if the number of monthly active users in the preceding calendar month exceeds or goes above 700 million users. While this number seems to be pretty large, you can imagine someone with a large traffic e-commerce portal hosting the model will hit this limit pretty soon. So it's very important to understand the fine print associated with custom licensed models. So these custom licensed models also come with gated models. What it actually means is after agreeing the terms and conditions, every user must request the weights needed to run the model because they are not available in the public domain. The custom license may allow both commercial and research usage of the model. For example, to run Llama 2 from Meta, you got to request to access the weights and the artifacts associated with the model. While the inference code is available on GitHub or Hugging Face, you still need to request Meta to download, to specifically get access to download the weights associated with the model. So only then you can technically run the model. So that means it is not completely open source, it's not completely closed, it's somewhere in between with a very specific custom license. Similarly, Stable Diffusion, a specific license that focuses on ethical and legal usage of the model. Now, it's your responsibility to comply to this license and it must accompany any distribution of the model. So this series focuses on leveraging open source and custom licensed models to build applications powered by generative AI. We'll explore how to choose the right foundation model for a specific task and the steps involved in customizing, fine-tuning, and integrating them with our applications. So stay tuned as we go through this journey. So I want to touch upon a very interesting aspect of foundation model that is called the supply chain. Just like traditional software, foundation models go through a pipeline that can be considered as the supply chain. So let's take a look at what this supply chain is and various stages of the supply chain. So there are multiple layers involved in the foundation model supply chain. There is a data layer where the quality and quantity of the data will have a significant impact on the performance of the foundation model. The data layer can become a bottleneck in the overall supply chain if it is not handled properly. So it can be difficult and expensive to collect and label large amounts of data, and this step is never compromised. The next layer is the compute layer, which is responsible for training the foundation model. The amount of compute resources needed will depend on the size and the complexity of the foundation models. The compute layer can also be a bottleneck because if the data set is large, we definitely need tremendous compute power to match the size of the data. So remember, ultimately the model's capability is dependent on the quality of the data and the quantity of the data used for pre-training. So after that, the next important stage of the supply chain is the foundation model developer layer, which is responsible for designing, training, and evaluating the foundation model. Now, this layer is typically consists of researchers and engineers with very strong expertise in machine learning and artificial intelligence. So, for example, the Facebook AI research or the Meta AI research, Google's DeepMind, and OpenAI research team are examples of the developer team or the research team responsible for training foundation models. So once they train the foundation model, then comes the host layer. Now, this is responsible for hosting and making the model available to downstream users via the download or the API access. Remember, we discussed 2 or 3 different mechanisms of licensing a foundation model. Depending on how the foundation model is licensed, it can be either pushed to a repository like Hugging Face, or it can be exposed through an API. But irrespective of how it is delivered to the developer or the end user, the host layer plays a significant role because it is going to be hosting the model, and it has to be ultimately scalable to handle the spikes and the demand that might cause depending on the popularity, based on the popularity of the model. And then comes the application developer layer, and this is where developers who are infusing generative AI into their applications step in and integrate their applications with the foundation model. So this layer typically consists of software engineers, product managers, and designers who become the consumers of the foundation model. And finally, the last stage of this pipeline or the supply chain is the end user. So the end user is the ultimate consumer who is consuming the application powered by the foundation model. So they have access to the application interface, and these users can be businesses, organizations, or individuals. For example, ChatGPT can be accessed by anyone who sign up with OpenAI. So they become the end user and they are interacting with the application user layer. And similarly, Bard is another example where end users can directly interact with a foundation model, which is Palm 2, that is working behind the scenes. So this is how the entire life cycle of a foundation model is typically handled, all the way from gathering the data at scale and processing the data to delivering it to the last mile end user who is consuming it through an application. And I give the credit of this graphic to Ada Lovelace Institute. So wrapping up, this section introduced us to the core concepts of foundation models that are at the core of generative AI. So in the next section, we'll get into the hands-on stuff where I'm going to walk you through the Vultr GPU stack to explore the infrastructure needed to host foundation models. We'll also see how we can bring an open source or a non-commercial model from Hugging Face and run it on the Vultr GPU stack. Stay tuned, and if you haven't subscribed to my channel, please do subscribe and click on the bell icon to get the notification when I launch my next video. See you soon.